let's get going here. Let me talk a little bit about Friday since we're getting closer. That's your quiz. It's on reflections, including the honors ones that we did that second day, translations, and what I'm about to show you today and tomorrow, which is rotations. Okay, rotations. There is no review tomorrow. There's no review day, I should say, tomorrow, but your homework tomorrow will be all review. Okay, if you want to get ready, your homework tomorrow is all review. All right, let's get into it. So we've gone over two types of rigid motions. Why are they rigid motions again? So what does not change? Side length or angle measure. So reflections, check that box. So the translations and what we're about to do, which are rotations. If you turn a figure, the side lengths don't change or the angle measure, right? Just a warning here. It's not. I don't think you guys will have any issues with it, but I think out of all the transformations we do, this might be the toughest one. Yesterday, I thought was the easiest translations. Turning a figure or points might be the toughest part. All right, so here we go. What do we need here? We need, for a rotation, where are we going to rotate around? What's my center? And I'll make that easy on everyone in this class anyway. It'll always be around the origin. Okay, we'll always rotate around the origin, 0, 0. Then we need to know what direction because, hey, I could rotate this way or I could rotate this way. How am I going to know which way to rotate, whether it's clockwise or counterclockwise? It'll all depend on the degrees. So take a look. Remember, we did reflections. What was my only symbol for reflection?
R.
Lowercase r. And I said, well, why is it an uppercase r? Because it's reserved for something. Here's what it was reserved for. Rotations. So you guys will see an uppercase r along with a subscript, like we've been seeing for reflections and translations. But this subscript will be in degrees. Not only is that going to tell you how many degrees we're going to rotate, it's going to tell you the direction too. This is positive 90. So this tells me this is a rotation 90 degrees. Ready for this? When it's positive, counterclockwise. All right, counterclockwise. If it's positive, we rotate counterclockwise. And I'm always I am done writing that word all the time. I'm going to abbreviate that CCW. All right, counterclockwise. Hopefully you're okay with that. Before I go to the next part, can everyone imagine in their mind what counterclockwise looks like? Right, you got the clock. If you even have to draw a clock, I would do it, right? Counterclockwise, going that way, all right, to your left. Counterclockwise. Well, what would happen if I want to go clockwise then? How do I know if it's not listed to go clockwise? Well, now it'll be negative degree amount. Yep, negative degrees. So that'll be a rotation. Still 90 degrees, but now we're going to go clockwise. And I will abbreviate that CW going forward. And just make sure clockwise means how the second, minute, hour hand goes on a clock. If you need a little tip to remember, when you rotate a positive amount, it follows the order of the quadrants. You guys familiar with your quadrants? 1, 2, 3, 4. 1 is in the top right. And then you remember how it goes? Counterclockwise. Okay, that's how we rotate, is we follow the order of the quadrants when it's positive. Okay, that's how I remember it. All right, you ready to do your first rotation? Yes, Anna.
If you don't put the degree sign, is it wrong?
No. If you have a capital R, that means rotation, so it's already assumed that that's a degree measure. For us today, we're only going to stay 90, 180, 270. Okay, multiples of 90. That's the only thing we're going to rotate. We'll rotate other degrees tomorrow. All right, take 30 seconds right now. Go ahead and graph triangle DEF so we can rotate this bad boy. sometimes I'll be nice, as I am in this problem, when I tell you that it's counterclockwise, all right? But I may just say rotate 90 degrees, and we got to know that's counterclockwise, but I tell you here. So real quick here, before we actually rotate the points, counterclockwise, we know we're going in that direction. So point E should end up in what quadrant? Quadrant 3, right? And points F and D should end up in quadrant. Okay, I just want to get something in my mind that at the end of this, I know I went in the right direction, because if E ends up in 1 and F and D end up in 4, I went the wrong direction. I went clockwise instead. So how the heck do I do this now? Oh, here we go. Some of you may or may not like it. We'll see. How do I rotate 90 degrees? You're physically going to rotate your paper 90 degrees for me right now. All right, well, everyone get it right in front of you now. Yep, right in front of you. Remember, we're going counterclockwise, so get that in your mind right now. Everyone ready? 90 degrees is just 1/4 turn, 90. 1/4 turn counterclockwise. So turn your paper right now. 1/4 turn counterclockwise. Everyone have that in front of them right now. In front of you, you have a new XY axis. Tell me where point D is right now on your new XY axis, because it's no longer 2, 3. It is no longer 2, 3 anymore. All right. Where did point D go to? -3, 2. And take a look. That's your new D prime. I know it's kind of weird. You know, you're tilting your head. D prime, -3, 2. I like to list all the coordinates. Then I'll go back to the original and graph them. So everyone keep going. E prime. E prime. Where is now E prime on here? E went to -6, -1. And one more time. F prime. -6, 2. Once we have them written down, we go back to my original graph and plot my new triangle that should be, as long as we turned our paper the right way, should be rotated 90 degrees counterclockwise. So -3, 2, D prime, -6, -1, E prime, -6, 2. Well, our prediction was right. F and D ended up in quadrant 2, E's in quadrant 3. So that looked good. And here's the part I love, is how do you know we went exactly? I know we turned our paper a quarter, but how do I know D is actually rotated 90 degrees exactly? I told you at the beginning, most of our problems, where's our center of rotation? We're always going to rotate around the origin, yes. So here's what just happened. And you guys don't have to put this. We rotated, I want a different color. We rotated D to D prime around the origin there. Guess what this angle is here? 90 degrees. We rotated through a 90-degree angle. Okay, and if you did the slopes, I guarantee they're negative reciprocals of each other. Okay, how about that, kids? Same thing if I connected F and F prime to the origin, E to E prime to the origin. Questions? So we just did 90. Hey, you might do 180. So now I go 1, 2/4 turns, and then 270, 1, 2, 3/4 turns. Okay, that's the only thing we're going to stick with today. 90, 180, and 270. Questions? All right, I don't think that makes us great. So let's try it. Let's just do a single point right now. 6, -3. That's point A. And does everyone see what I'm asking you to do? If anybody's wondering, that O right there, sometimes we may see that. That's just short for we're rotating around the origin, okay? So don't get freaked out. We're just rotating like we usually are around the origin. 180 degrees. 180. All right, let's take our paper right now. 1 quarter turn, now we're at 90. 2 quarter turn, a second quarter turn, now we're at 180. I take a look on my new XY axis. And where is A prime now? Where did it land here? When you're ready, where did it land? I'm going to land Violet. Where did it land? -6, +3. That's where mine landed as well. And just to do a quick check, -6, +3. Yeah, absolutely. Because 90 degrees, 180 should have ended up 2 quadrants away. Yep. Okay, let me stop here before we answer to part B. I understand some of you might be uncomfortable with this whole turning your paper method. I get it. So I have an alternative method, which is at the bottom of your page, please. Look at the bottom of your page. What I've done is in function notation, I have given you the rules for rotating 90, 180, and 270, if you prefer to memorize those. If you like turning your paper, keep going. If you feel uncomfortable turning your paper, you might want to take a look at those rules that are in function notation up there. Okay? What I don't have up there, can we talk about this real quick before I go down back to part B? What I don't have are the negative rotations. I only have +90, +180, and +270. But can we put our thinking caps on here, honors? A rotation of +90 is the same as a rotation of -270. Rotation of 180 is the same as a negative rotation of 180. It doesn't really matter what way you turn your paper, right? You can't go wrong. And then a positive rotation of 270 is the same as a negative rotation of 90 degrees. So again, if you want to memorize them in function notation, fine. You want to keep turning your paper, fine too. Any questions? Yes, Will, go.
On the test, are we going to have a graph? Like for all?
I will always provide scrap graph paper on the back. Okay. Yes. Yep. Whether I require you to use it or not, there'll always be a scrap piece of that graph paper on the back. Sophie.
Will there be a question where you said that like we have to use?
Absolutely not.
Okay.
No, absolutely. You rotate however you feel comfortable. Okay, anybody, we good on rotations? Because I'm going to go to something new now. Day 1. What was day 1's topic? Anybody remember? What transformation? Reflections. And it was always reflecting over a line. To end class today, we can reflect over a point too, or through a point. Okay, we can reflect through a point. So point A is going to stay where it is, and I want to reflect it through the origin. Origin. Reflections are rigid motions, correct? Because distance does not change. All right. So whatever the distance is from A to the origin, better be the same distance from the origin to wherever we find A prime to be. Okay, those distances need to be the same. But I got good news. Don't worry. I know some of you are thinking, oh, this guy's going to let me have to do distance formula again. He's going to laugh at us because it's awful for me. No distance formula needed. No distance formula needed. We're going to do a little slope here, and I'll show you why it works when we're done. From A to the origin, up and over how many? From A to the origin, up and over how many? Up 3 over 6, right? I go up 3, and you don't have to mark this. Up 3 over 6. Match it now. Do it again. Do it again, and you'll land on A prime, which happens to be. Go ahead, go up 6, or up 3, sorry, up 3. Whew. Up 3 over 6, and where did we end up? Same spot, which I wanted that to happen. Whoa, why does this whole slope thing work for reflecting through a point? You guys don't see it, but remember what we said? Reflections don't change distance, right? We just use Pythagorean theorem. A squared plus B squared equals C squared. Well, if my A and B are the same, so should the C. That's all we're doing there. So that's why slope works, because you're kind of doing a version of Pythagorean theorem, showing me the distances are the same. Okay? All good? So we reflect through a point, and we're not done yet. I want you to use slope and match it. And what else did we just find here too in parts A and B? If you do a rotation of 180, it's the same as a rotation of 180 is the same as a reflection. What's the symbol for reflection? Lowercase r through what point? There you go. These are the same transformations, even though one's a rotation and one's a reflection. Look at that. Okay. I love it. All right, reflecting through one point doesn't make us great at all. Let's go. Yeah, I'm sure you do. Go ahead.
Instead of writing origin, do we have? Can
You
we
could
just
write 0, 0.
0?
Yes, you could. What's your deal back there?
Oh, could you like go over instead of starting up? Could you like?
As long as you match that on the other side of the point you're reflecting through, yes. Okay. All right, let's keep it going. All right, triangle art, graph it up. Triangle art. Okay, we're going to reflect it through 5, 2 now. The point 5, 2. 1, 2, 3, 4, 5. All right, we're going to reflect it through that point now. Should be on the other side. A, R, and T should be on the other side of 5, 2 there. All right, let's do this together here, but I need somebody to make a class decision here. Oh, Zach, good. A, R, or T. Which one do you want me to reflect first?
Let's go.
This is painful. T. All right, thank you. All right, here we go. T. I'm going to use slope. Down and over how many here? Down 1 over. No? I'm not going down 1 here? Or did I graph this wrong?
Yeah.
Down 1 over 3?
Yeah.
What am I missing here? Some people are yelling at me here. Right? From T to 5, 2, the point of reflection, I go down 1, left 3. So go ahead and match it. Down 1, 1, 2, 3. This is where T prime should be. Again, I'm guaranteed those distances are the same because we just did a little version of Pythag. So what's T prime? 2, 1? Oh, it does say state, so we better be writing them down. All right, next up, who's going to do it here with me? And you got to do it with me. Will, you're up. What a point you want to reflect with me? A, all right. Down and over how many?
Down 1, right 1.
Down 1, right 1. So do it again. Down 1, right 1. What point's that one here, Will, for A?
6, 1.
6, 1 looks good to me. A prime. And now we got to do R together. Let's do R. Boom. Sophie, ready to go?
Yeah.
Okay, R to 5, 2. Up and over how many?
Up 1 to the left 3.
Do it again. Up 1 to the 1, 2, left 3. Yep. And that's going to be R prime. What do you got for a point there, Sophie?
2, 3.
2, 3. Good. There it is, reflected over through that point. Questions? And finally, we did this on day one. You guys did a lot of reflecting over a line. Now I want not the line of reflection, but what point did I reflect over? Talk it in your group. I don't want to give this one away. Talk it in your group here. You know how to find the point. You know how to reflect through a point, but how do I find the point of reflection here?
Yeah, you're right. No, it's yours.
Do you guys have
All right, here you go. Here you go. Let me talk about this because I'm hearing a lot of different conversations. I know some of us have it right away. Some of us are having trouble, which is fine. Before I even start sniffing around the point of reflection, we got to know which one's the image and which one's the pre-image because there's no primes on this one. And you'll see that from time to time. It's not A prime, B prime, C prime. Triangle DEF is the image. So I need to know what pre-image point matches up with its image. In this case, A matches up with the first letter, just like in congruence. D, I got B matching up with E, and then I have F matching up with C. And I'm not going to do this for all three. I'll just do it for two of them. So as I go from A to D and I notice it's a point reflection, my mind starts thinking slope, slope, slope. So as I go from point A to D here, I'm going down 4, down 4, left 2 to get there. That's how I went from A to D. But I know if I'm going to find the point of reflection, it's going to be halfway between those. All right, if I'm going down 4, left 2, I got to cut that in half. So my point of reflection is going to be at down 2, left 1, should be. I'm never confident just doing 1, though. So I go down 2, left 1, there I am. I think that's the point of reflection, but we're in honors and I want to be on the safe side. So I do the same exact procedure from B to E. B to E, what do I have? I went down 8 and left 14. Wow. I had to count a while for that. So my point of reflection should be at down halfway, 4, left halfway, 7. And from B to E, if you go down 4, left 7, we're going to be right here again. Okay, so that's how I find my point of reflection. I do the whole slope from the pre-image to the image and cut it in half. And that point, let me finish this off strong. That point of reflection, 1, 2. Jacob, that point of reflection. There you go. Regents question right there as well. All right, we got plenty of time here today. 5, 10, 15 minutes, 16 if we're going to 51.